Hello, everyone, and welcome to another episode of AWS Partners Unplugged, the podcast where we dive deep into the world of AWS partners and how they can leverage the cloud to build incredible things. I'm your host today, I'm Igor, and we are tackling a topic that is crucial to every AWS SE partner, building on the cloud and its resilience. We have a true expert with us, Tarek Makota, a senior principal solution architect at AWS who spends most of his time working with customers on resilience. Tarek, great to have you with us today.
Thanks for having me, Igor. It's actually happy to be here and happy to be back with ISVs. When I started with AWS, I was actually working with a bunch of ISVs customers.
Absolutely, and actually, that's how we connected in the past. And for our SV partners who might be new to some of these concepts, can you start by explaining the basic building blocks? What's the difference between the AWS region and availability zone, and why should an ISV care?
Perfect. That's actually a really good question. I think the key construct is the fault isolation boundary. So all of these constructs, which I'm going to jump into, are basically representing fault isolation boundaries. So AWS region is a geographically located location. It's about 60 miles in a radius that is composed of multiple availability zones. Availability zones are composed of one or more data centers. And these two contracts are both representation of the fault boundaries, meaning they are set up in such a way that they prevent the blast radius out of that fault boundary. For example, impairment in one availability zone, it would try to contain it with that availability zone so it does not spill into the others. This is much akin to the shipbuilding, basically the concepts of the shipbuilding, where you basically have compartments and you try to prevent the water spilling from one compartment to another in case of an impairment. This is actually critical for ISVs because they have a customer of their own, and these regions and availability zones are basically designed to protect against major events like the grid failures, natural disasters, and then to build resilient application, understanding how to utilize availability zones, regions, and how to actually conduct traffic between these becomes important to get the highest levels of resilience that you can in your software.
Fantastic start. So once our ISV partners understand the regions and the AZs, how they should think about AWS fault isolation boundaries, why does it matter to them? I mean, I know they're working with their customers and they probably hide that complexity away from the customers, but yeah, what's the important part?
I was using that analogy of shipbuilding and bulkhead patterns. So for all of those that have ever watched any movies where there's submarines, and if there's some sort of a catastrophic failure or any type of a failure in the submarine, you see in the movie that they basically close those compartment doors. And those compartment doors get closed to basically prevent the whole submarine basically either sinking or having an impairment that's basically unrecoverable from. You can very much think of these, of the regions and availability zones used in the same thing. If you think of region being a submarine, these multiple availability zones being the compartments, what you want to try to do if there is a leakage in one of those compartments, you want to prevent getting into the other compartments because those could be detrimental sinking of the submarine. So to translate that in application development, if I am servicing large number of the customers as ISV, I want to make sure that those customers have the best experience and most consistent experience as possible. I want to basically put an effort in my application being able to sustain itself and sustain the business that my customers are actually conducting with my application by taking advantage of these constructs. So if I build my application in mind with these fault boundaries, then I can basically have an impairment that can be contained. And instead of having an impairment across my whole customer base, I have it on a subset of the customer base. So for example, availability zones are basically very important at building what we refer to as availability zone isolation patterns. Now, besides these, Understanding the fault boundaries and how we construct our services is also the concept of the control planes and data planes. AWS services themselves, by large part, are broken into the two main constituent software parts, which is basically control planes and data planes. Control planes orchestrate things, and these are, if you think about it, control planes allow you to create the resource, to update the resource, to delete the resource, to list the resource. And then the data plane is basically the communication between those resources or the normal operation of the resource. So for example, in terms of the database, the control plane operation would be starting the RDS database. RDS database itself would be the data plane. Knowing how to use these, the data planes are generally more critical, and you want to keep them up and running. So using and how to depend on these things is critical. For example, if there's an impairment of any one control plane of AWS services, what can I do to basically decouple my application and basically soften that dependency in those cases? So for example, if it's an EC2 instances and let's say there's an impairment, I may not be able to start new EC2 instances. What I can do is I can pre-provision and keep the warm pool of some of these instances to kind of help myself around these things. When it comes to all of these things, knowing how to use the fault boundaries to the advantage to basically prevent the impairment from basically spreading to the whole application and creating the larger impact is the key.
So these are huge takeaways for our partners, and there's a lot of things to parse there. So partners developing ISV partners. We are talking primarily ISV partners here. So control plane, data plane pattern. Yeah, I've seen this as well. Many partners develop that. It's not just to think about multiple AZs. You have to think how these AZs, how the separation applies to control plane, data plane, how to design them. And thinking of design, what are the common misconceptions you see ISV partners have when thinking about single region resilience?
Yeah, I think one of the biggest misconception is that using the single region, I cannot achieve availability or resilience. Or conversely, that multi-region architecture inherently provide a high resilience. To give you examples, let's assume that I have a multi-region solution. Let's call it an application. And in that application, I basically, from the region number 1, I make synchronous call to the database in region number 2. In this case, what I basically have done, I have taken a strong dependency. I made the dependency between the region 1 and 2, assuming that there is an impairment in either of the region. I would basically have some sort of impairment in this case because it's a synchronous call that I'm making. So if the secondary region is impaired and that functionality doesn't work, I'm going to get an error. If the primary region is not working, I will have an impairment. So designing with a multi-region does not automatically out of the box give you higher resilience. You have to basically abide by the fault boundary. So I was talking about region being a fault boundary. I, in my application, can break that fault boundary by taking the hard dependencies between the region A and region B. So in some cases, the single region can achieve higher availability and resilience. And in the case of stateless applications, that's much actually then easier to basically take my application and basically start it up in a different region. So another one that's kind of that's also a misconception is a lot of the applications, especially things that have traditionally run in a data center. So if you think about the data centers that is on-premise, that is also a fault boundary, right? So if I have an application that runs in a data center and that is my fault boundary, and I take that same application, I stretch it across 3 availability zones in a region, I might assume that I have a higher level of resilience because I have 3 availability zones. But my application might be breaking those fault boundaries between the availability zones, meaning I might be taking hard dependencies between availability zone 1 and availability zone 2, in which case I'm negating the benefits of the fault boundaries. This is another misconception. So when the customers take the applications that used to run perfectly fine in the data center or the ISV solutions, one of the things that should be ensured is that impairment of availability zone, which can be tested using the zonal shift or the fault injection simulator, that I can my application can operate with the loss of availability zone. That's definitely something to test.
So I want to ask you like orthogonal questions here.
Yep.
Question. Some partners do offer multi-region solutions. And let's say I'm an ISV partner and I've started with a single region, and you're saying this is perfectly fine and it will work and it's resilient. Do I need to offer a multi-region solution, or like what's your take?
It depends. It all depends on the business requirements. And multi-region, when we talk about the multi-region from the standpoint of resilience, what we really mean is that my application is basically having instances in two different regions that are basically identical, or they basically can take a function of each other. I'm basically talking about the redundancy in a nutshell. That redundancy can come in multiple forms. I can have active setup, meaning both regions, my application, both regions is receiving the traffic, and both regions are processing the traffic actively. So when we talk about multi-region in terms of resilience, that's what we mean. When it comes to the ISVs, multi-region can also be interpreted. I have a solution and I am deployed in 36 or 37 different regions. The question that I would ask is then, it basically goes from the customer standpoint of those ISVs. If it's deployed in 36 or 37 regions, I, as a customer of that ISV solution, if there's an impairment in a region A, can I go to the region B? And how does that work? Does my data make it to the other side? What is the lag of that data, replication-wise, right? So when it comes to the multi-region, the question already, with the multi-region, you basically build for the higher and higher levels of resilience. Like we spoke about earlier, it does not automatically mean having the application to region does not automatically mean that I'm more resilient. It needs to be architected in such a way where I'm honoring the fault boundaries and I'm not basically breaking them. And then making sure that the data replication is in concert with my requirements, right? So recovery point objective, how much data I can lose. In some cases, I can't lose any. And what do I do then? How do I actually make sure that the replication works? This is where we usually come into from an ISV standpoint, solutions like Aerospike do these things, Cockroach does these things. AWS specific implementations examples are the SQL database or the DynamoDB with a strong consistency for the multi-read.
So sounds like it's more of a product decision and what customers are asking. And doesn't sound like there is a single multi-AZ or multi-region silver bullet without a proper design. So how should ISV partners then start thinking about resilience for their critical applications? Like if all 9, we always think about, how many nines of availability and resilience you have. If that's not the case, not the sole focus, what should they think about?
Yeah, there's a couple of things, a couple of key considerations. So taking the nines out of the picture for now, like the first thing that I would think about is how do I contain that blast radius, right? If I focus on the blast radius and if I can contain the blast radius, that should directly impact and improve the number of the nines I'm achieving. So for example, let's say that I am considering breach of my SLA is when more than 10% of my customers cannot use the solution in a period of 5 minutes, I'm going to count that as a 5-minute period. So now, if you think about containing the blast radius, if I can contain the blast radius to only 5% of those customers, I will not breach that SLA of 90% of the customers being impaired. So that definitely helps. There's a number of other things. We always want customers to have the best experience possible, but sometimes we need to protect the application for those customers that are already inside of the application. So, for example, handling the excessive loads. This is pretty prevalent for the SaaS providers. This is very much akin to us going to the restaurant. Like when we sometimes go to the restaurant, you get there and they're like 30 minutes wait. That is basically them handling excessive load, right? They have a set of customers that are already sitting at table, they're dining, they're at the full capacity. If they let all of us get in, we would have to sit in their laps or eat at their tables, and that's not the experience for anyone at that point. So kind of thinking about that excessive load and how to make sure that you give the best experience to the customers that are already there, and protect them, basically protect the additional ones from overloading. Because these are all tough decisions, because you inherently have to say no to some of the customers when these things happen. So I think some of those things are critical things. There's also the whole thing around the retries. Generally speaking, developers love to do the retries. Being careful, but we got to be super careful about the retries. In my opinion, if I am an ISV that has a SaaS solution, I might have millions of customers, and if 100,000 of them have to retry, and then I retry 3 times in a row within a half a millisecond, I'm basically creating much more traffic than I can take. So I can actually kind of create impairment on my own. So I think the retries and having the backoffs and adaptive retries is another key. A lot of these things are the lessons that we have learned. What I would suggest to all of the ISVs is to go to AWS Builders Library. That basically has the learnings from our software development teams, from our engineering teams around these practices.
I liked your analogy of the restaurant. I wanted to bring up another problem of noisy neighbor. You come to a restaurant, you have a table next to you where people are noisy, and you might be asked to escort them into a private room, right? So they don't spoil experience for everybody else. And that's a strategy, I guess. But great insights. So yes, when you started talking about the specialty of SaaS providers, you've talked about control plane, data plane. Many of our listeners are offering SaaS products, and that's what we are primarily targeting in the podcast. So what other special considerations should they keep in mind when it comes to resilience?
Yeah, this is the most important part is practice makes perfect. And what I mean by that, it's kind of like going to a gym, right? So when it comes to software development, practice makes perfect means I am continuously testing my software. The most extreme side of that is the example is of the Netflix Chaos Monkey. But the customers can basically use different tools to test various impairments. Like I don't have to necessarily simulate impairment in production to find out whether my application can sustain certain impairment or not. To give you a specific example, we were talking about availability zones and whether my application is taking advantage of the fault boundaries of availability zones. Using the fault injection simulator, I can simulate the power outage in that availability zone. And basically that would simulate a scenario in which availability zone is unavailable. Then I test my application. Is it still behaving correctly? Do I need to do something to it? That's a step one. And the next one is I might add actual production load to my application and then repeat the scenario. is application still behaving the same way? The answer may be yes, maybe no. So I think the other part of it is that I would say is every ISV software, every application will have a set of quote unquote user journeys, meaning the things that the workflows which users are executing to achieve some sort of a outcome inside of the software. Not all of them are created equal. Some are more important, others are less important. So for example, if I am selling widgets, my most important journey might be that my users can buy the widget. Less important journey might be that I am able to add a new widget to the inventory for the people to select, and so on and so forth. Test is probably the best advice I can give them.
Right. And we actually had episode on resilience lifecycle framework. You mentioned testing, and there is also resilience analysis framework. Can you talk a little bit about how they're different and what is the purpose of each?
So the resilience analysis framework is basically developed through the experience of various AWS solution architecture teams in the field that work with the customers across industry. It basically targets the builders across many different titles, from managers to software developers, engineers, etc. Basically, if you are developing software, it is intended for those of you. The purpose of the resilience analysis framework is the guidance around how to consistently analyze failure modes and how would these failure modes impact your workloads. Example I was giving previously about test is a specific example of that. So the resilience analysis framework kind of classifies potential failures into the different categories. And then through the analysis of these user journeys, it allows you to basically go and analyze and rationalize what type of failures could happen. So for example, one of the category is single points of failures. What do you want to do in single points of failures, analogy-wise? So for example, in airplane industry, I might have an airplanes with a single engine and then airplanes with multiple engines or two engines, right? So airplanes with a single engine have a potential of single points of failure, aka single engine. Desired fix for that would be to add the redundancy, add the second engine, and add the second engine in such a way that single engine can maintain the airplane in flight. So we do want to do the same thing inside of the software. When it comes to the software, for example, is if I have a single EC2 behind the load balancer, I may want to add two of them in case one of them goes down. It's a very benign example, but that's the example of the resilience analysis framework. So the resilience analysis framework, we are actually allows you to take the ownership of the failures of the modes of your application. It allows you to reason about these things, and then it allows you to basically meet your objectives. Some customers use the recovery time objectives or recovery point objectives. Some use SLAs. Others use mean time to recover and mean time before failure for the various measures. So resilience analysis framework allows the customers to basically rationalize and analyze these failures and act, and then basically test these failures and incorporate the mitigations into their software.
Those analogies are really hitting home. Actually, fun fact, for a long time, cross-Atlantic flights did not allow airplanes with two engines. They allowed only four engines.
There you go.
We should have the same policy, like depending on the criticality of the workload, you should have 3 AZs or 7 AZs or 5 AZs. But beyond these design principles and analogies, I know AWS innovates, creates new services and products. Are there any specific services that can help ISV partners to build more resilient applications? And Where does AWS take more of the heavy lifting away from the partners so they can deploy their products sooner, faster, get better at the quality, and get sooner to market?
Yeah, when it comes to resiliency-specific services, there's a handful of those. So for example, application recovery controller. Application recovery controller is intended to assist the customers recovering their application and utilize the best practices of the multi-region. As part of the application recovery controller, there's a service that's called an auto shift, zonal auto shift. Zonal auto shift basically allows the customers to exercise these switches of the traffic inside of the zone, meaning if there's an impairment in the zone, switching the traffic away from that zone is something that basically the zonal shift helps with. Fault injection simulator allows customers to basically simulate some of these impairments. And by simulating the impairments, you then find out how your application would behave in case of the real impairment, which then allows you to actually put the offsetting things. In addition to that, we also speak a lot about shared responsibility model. So for the customers, there's a set of customers that want to take a full control of their resilience, and they want to take a full control of that shared responsibility model. And then there's a set of customers that would prefer that we basically handle as much as possible. So for example, Amazon Connect is the SaaS solution for the contact center, where this is where Amazon would take more of the responsibility when it comes to the resilience, right? If you think about it, then in our container services, right? I can run our container services, whether it is ECS or EKS, and Amazon is responsible for the underlying infrastructure and the control plane operations of those clusters. But then I am responsible for the worker nodes and things like that. Or I can actually offset some of those responsibilities with worker nodes using EKS Auto Mode or ECS Fargate. Another example of this is also Lambda. I can run my workload on EC2 instances or the containers. On EC2 instances, I have to do a lot of work, and I am responsible for the resilience of those instances once they're up and running. If I can actually utilize AWS Lambda, and AWS becomes responsible for having provisioned enough resources for me to execute those software functions. So there's a number of the things, a number of the services. Some of them are resilience specific. Others basically shift a responsibility model and kind of allow you to do more or less depending on which you want to choose. And selecting the right service for the right use case, and then abiding by the fault boundaries and taking advantage of the fault boundaries can yield high levels of SLA that you were asking about before.
That's incredible value for our customers that AWS provides. And it sounds like there is a spectrum of control and shared responsibility. To wrap things up, what's your ultimate parting advice for ASE partners as they refine their multi-AZ, multi-region strategy?
Yeah, in general, this might be life advice, actually. Question everything. When I say question everything, when it comes to the resilience, whether this is really pronounced with the customers, I don't know how much pronounced this is with the partners, but making sure that there's a common understanding around the recovery time objectives, recovery point objectives, meaning these are defined by the business, aka these are then implemented by the technology itself. A lot of times I will hear, recovery point objective 0, recovery time objective minutes. And then as we start getting into the discussions, well, how do you do it now? And then you get to the bottom of it, and it's kind of like, well, it's not really being met right now. It is desired properties, right? Whether you use recovery time objectives, whether you use SLAs, or whether you use mean time to recover, measure, I think the key part is knowing what your measurements are and implementing the ways that those can be improved. Like my measurement today might be 30 minutes of the maximum outage I can, and I can basically recover it. How do I get better about it? Can I get better about it by early detecting that there is an issue, by having some sort of an automation, or any of those and above? So the key thing is know where you are currently, and then start working towards improving those towards your desired outcomes. It can take time, it can be painful, but then also we were talking about the resilience analysis framework. There are many different ways that my application can fail. I would say in every sprint, if the teams are using Agile, try to add an exercise of how can my application fail? And maybe that is, impairment of thing X or bad software deployment. And then look at all of the things that can cause that, and look at all of the ways that can prevent that, and then all of the ways that can mitigate that, implement those. And if you do that every sprint, if you're running 10, 12, 30 sprints, there's going to be 10, 20, 30 improvements. So the key here is that resilience is not a point-in-time thing. It is a continuous improvement over the period of time. And unfortunately, it never stops because new vectors of the failures are added, just like in security. Like new attacks are invented on a daily basis. The software is basically becoming more complex. We went from mainframe to the client server to the T-tier, 3-tier to the distributed, now to the agentic. So the different things can fail differently. Understanding how they fail and proactively acting on them versus reactively is usually the best way to kind of do these things.
So know your objectives, question everything, and resilience is a continuous process. Those are powerful parting words, Tarek. This has been an incredibly insightful conversation, and I'm sure our SE partners will have a lot to think about regarding their resilience strategies. Tarek, thank you so much for joining us at AWS Partners Unplugged today.
Thank you, Igor. It was my pleasure, and hopefully it got everyone thinking more critically about their resilience.
Great. Thank you, everyone, for listening, and be sure to subscribe to AWS Partners Unplugged for more deep dives on how you can succeed as AWS partner.